Welcome to the Gates Accessory Belt Drive System training video. This short video covers important information that will help technicians resolve common problems with belt drive systems. Applying what you learn here will improve system performance, increase component life, and reduce customer comebacks. Automotive technology changes quickly. To be successful, shop owners and technicians need to keep up with the latest training. They also need help explaining to their customers the importance of preventive maintenance, including the need to replace critical wear parts before they fail on the road. Customers need to know that the belt, automatic tensioner, idlers, pulleys, and powered accessories are all highly integrated in a serpentine drive system. The system approach to repair and maintenance, then, will result in the best component performance, longest life, and fewest customer comebacks. Here's what you need to know. The most important component in a healthy serpentine belt drive is the automatic tensioner. The tensioner and belt are designed by original equipment manufacturers as a system. They have the same design life, so they must be replaced together to maximize system life. When the ABDS is working properly, all accessories are running as they should. The alternator, for example, will be spinning at the design speed, creating electricity to power the vehicle and recharge the battery. As the belt slips, all of the accessories operate at diminished output. The amount of electricity produced by the alternator, for instance, will fluctuate with belt slip. This may lead the motorist to conclude that they have a bad battery or alternator, when the problem is actually a worn belt or tensioner. The check engine light may even come on with an unrelated trouble code. The accessories are inefficient and their life will be shortened by the additional stress placed on them. Not replacing the belt and tensioner together will lead to problems. This chart, for example, shows that a slipping belt is one of the top 3 reasons for customer comebacks after replacing the alternator. The slipping belt is caused by a failure to replace the automatic tensioner. Belt slip damages the belt, decreases accessory efficiency, generates false trouble codes, and creates noise. It can also generate enough heat to damage the grease in accessory pulley bearings. The tensioner ensures sufficient tension to power the accessories. As the tensioner wears, the belt can slip at the accessories, causing noise and excessive heat at the accessory pulleys. The alternator is especially vulnerable to heat damage, since the pulley is much smaller, turns faster, and has a higher bearing load. All original equipment tensioners, and most aftermarket tensioners, like this one, have an internal damping system that controls vibration and power fluctuations. This damper looks and acts much like a drum-type brake. It rides against the inside of the tensioner housing and limits the amount of tensioner arm movement. The damping mechanism is critical to controlling vibration and power fluctuations. As the damper wears, it can no longer effectively limit tensioner arm movement. The belt then slaps against the next accessory, quite literally hammering it to death. Eventually, the accessory will fail prematurely. A worn damper will no longer make sufficient contact with the housing, and important damping effect will be lost. Another wear point inside the tensioner is the pivot bushing. As the bushing wears, the tensioner arm can move out of alignment with the rest of the belt drive system, damaging the belt and creating noise. The round spring on this tensioner is effectively sealed inside the tensioner housing so it does not rust or bind up. This technology is patented. So competitive tensioners, like this one, use a flat spring. Technicians should carefully examine the flat spring tensioners since dirt and moisture can more easily contaminate the spring. Grit can wear through the Teflon tape that separates the spring coils and allows rust to lock up the spring. Also, notice that a damper is missing from this tensioner. Aftermarket flat spring tensioners, like this one, do not have a damping mechanism like their original equipment counterparts. Additionally, the pivot bushing on flat spring tensioners is lubricated with grease. Grease attracts grit, and grit will wear the pivot bushing prematurely. There should be very little movement of the tensioner arm at engine idle and very small movement during accessory loading. A worn damper will allow the tensioner to bounce or vibrate at idle and move excessively during accessory loading, which means that the tensioner needs to be replaced. With a technician's stethoscope, Listen for telltale signs of bearing problems. Hissing or growling sounds coming from the pulley are indications of potential bearing failure. With the engine off and the belt removed, inspect the tensioner pulley. It must spin freely and have no grease seeping from the bearings. With a socket wrench, move the tensioner arm slowly through its range of motion. It must move smoothly. A sticky or notchy feel in the arm movement indicates spring wear. There should be no movement of the arm toward or away from the engine, perpendicular to the direction of the belt travel. Any movement of that type indicates a worn pivot bushing and the need for replacement. Examining the condition of the belt is also a good test for a worn tensioner. Shiny or glazed belt ribs indicate belt slip. Look for any signs of abrasion along the cord line. You can see that the tensile cord on this belt is slightly frayed. This means that one or more of the pulleys are out of alignment, or that the tensioner pivot bushing is worn. Serpentine belts are also designed to flex around pulleys and idlers in the direction of rotation. They are not designed to flex sideways. As the belt runs through the accessory belt drive system, all of the pulleys should be in alignment. A tensioner will cycle 1 billion times over 100,000 miles, causing the tensioner pivot bushing to wear. When the pivot bushing wears, the tensioner arm can move out of alignment. This causes the belt to run uphill on the pulley, damaging the belt and causing noise. The system can only tolerate 1 degree of misalignment. For each degree over that, 30 degrees of heat is generated for the belt and bearings. Pulleys or idlers that are skewed or out of alignment by as little as 1 degree can create belt chirp as the belt ribs slide down one side of the pulley grooves rather than mate with both sides at the same time. Installing a new belt will temporarily fix the problem, but the noise will return quickly. Here's why. Many serpentine belts installed by professional technicians are constructed with special fibers in the belt ribs and the undercord. These fibers help the belt run quietly in pulley grooves, even in misaligned pulleys. As these fibers wear, however, the belt becomes more aggressive as more rubber material contacts the pulley grooves. If the pulley grooves are not in proper alignment with the belt ribs, they can chirp as the belt ribs slide down one side of the groove. These fibers can be worn away in as little as 3,000 miles, and the chirp will return, along with your customer. Belt slip can be caused by a worn tensioner, but it can also be caused by worn, contaminated, or misaligned pulleys, a high mileage belt with more than 5% material loss, or a belt that is stretched or is too long. Notice that this older belt has quite a bit of rib cracking. Some cracks are a normal part of belt aging for older neoprene belts. Neoprene belts with more than 3 cracks in a 3-inch section of one rib means that the belt has reached 80% of its intended life and should be replaced. Although some neoprene replacement belts are still sold in the aftermarket, the industry standard for original equipment and replacement belts is a highly crack-resistant elastomer known as EPDM. EPDM belts typically run 100,000 miles with no visual cracks, so a better indicator of wear for EPDM belts is material loss. Like tires on a highway, belts gradually lose rib material over time. Material loss of as little as 5% can cause belt slip, noise, and performance problems, including early component failure. Worn belts can also hydroplane in wet weather. Here's why. A new belt mates tightly with the pulleys, providing necessary traction while leaving a channel to evacuate water and other debris. The belt loses material with normal wear. With just 5% belt wear, the belt will not mate properly with the pulley, losing traction in the ridges. The belt just rides over the pulley, wandering and slipping over the top instead of transferring power. The evacuation channel gets distorted from wear, which allows water to channel between the sides of the belt ribs and the sides of the pulley. With less contact between the belt and the pulley, the belt has a tendency to hydroplane and slip. Technicians can easily check serpentine belts for material loss with a free tool available from Gates. When the gauge is placed in the grooves of a new belt, the top surface of the gauge sits above the belt ribs. As rib material is lost, the gauge will ride lower in the belt groove. If the top of the gauge does not extend above the ribs, a significant amount of rib material has been worn away and the belt replacement should be recommended. This go or no-go method of belt inspection is quick. can be performed with the belt still on the engine and gives technicians the confidence they need in recommending belt replacement. Here's another important tip. The height of the tool should be the same in all belt grooves. If not, the technician should remove the belt and check for pulley misalignment and pulley wear. In addition to the free plastic gauge, a new pick gauge phone application is available from Gates. With a smartphone's built-in camera, take a picture of the ribs of any K-section serpentine belt and the application software instantly analyzes the degree of belt wear. Show your customers the results and see how much easier recommending belt replacement can be. Protect your customer's investment by understanding that today's belt and tensioner are manufactured with the same product life cycle and should be replaced together. Replacing one and not replacing the other may lead to customer comebacks. Also remember that when other drive components, such as the alternator, are ready to be replaced, chances are the belt also has considerable mileage and wear. Installing a new belt rather than reinstalling the old belt actually saves your customer money down the road. The labor cost for belt installation is already built into the job you're there to do. In fact, the labor savings alone makes the belt free to the customer compared to paying additional labor on a separate belt replacement job. For additional accessory belt drive system information, please visit our website at gatesbeltwear.com. Gates also offers a variety of training on belts, hoses, and hydraulics via the Performance Center at gatesaftermarkettrainingcenter.com.